In this video, we're going to be learning about a new idea called the central limit theorem. This is a rule that we'll be applying in future videos. In this video, we're just going to get an overall idea of what the central limit theorem tells us. It's a rule that's used to predict the shape of a sampling distribution of sample means. In an earlier video, we learned about the idea of a sampling distribution. We learned that if a population is randomly sampled and a sample mean is calculated, there are different possible samples that might be selected. Each possible sample has a sample mean, and those sample means have a sampling distribution. The central limit theorem allows us to predict what shape the sampling distribution will have. According to the central limit theorem, when a population with a normal distribution is sampled, the sampling distribution has to be normal, no matter what sample size is being used. When a population with a skewed distribution is being sampled, the sampling distribution will be roughly normal if the sample size is 30 or larger. I think this rule will become a little more clear if we look at some diagrams. So here's the first situation. In this situation, a population has a normal distribution, or a bell-shaped curve. A random sample of 10 is being selected from the population, and the mean of those 10 is being calculated. In this situation, the sampling distribution has a normal distribution to it, because if the population is normal, the sampling distribution has to be normal. The sample size doesn't matter. So in this situation, these the means of the different possible samples of 10 people have a normal distribution because the population is normal. Here's another situation. In this situation, the population is skewed, a random sample of 10 is being selected, and the mean of the sample is being calculated. In this situation, the sampling distribution is skewed, just like the population, because the sample size is less than 30. If the population is skewed, the sampling distribution will be skewed when the sample size is less than 30, and will be roughly normal if the sample size is big enough, meaning 30 or larger. Here's our third situation. In this situation, the population is skewed, and the sample size is 30. We have a skewed population, a random sample of 30 is being selected, and the mean of that sample is being calculated. In this situation, the sampling distribution does have a roughly normal shape because the sample size is big enough, the sample is 30 or larger. So we've looked at three situations. We've looked at a normal population and a small sample size of 10. We've looked at a skewed population and a small sample size of 10. And we've looked at a skewed population and a larger sample size of 30. In both situations, in the situation in which the population was normal, the sampling distribution was normal. In the situation in which the population was skewed, the sampling distribution was only roughly normal when the sample size was big enough, 30 or larger. When the population was skewed and the sample size was smaller than 30, we had a skewed sampling distribution. And in future videos, we'll be talking about how there's some calculations that can only be done if the sampling distribution is normal. And that means that those calculations can only be done if either the population that's being sampled is normal or the sample size is at least 30, both of which will make the sampling distribution at least roughly normal.